Hey Red Devil Chemist, how you doing? It's Coach Scott with another rendition of Let's Work a Problem Out. So again, we're on worksheet 4S. 4S, we're looking at problem 20. Lots of neat meat in this problem right here now. Lots of meat, okay? We're dealing with dilutions. We're dealing with concentration of solutions, right? So this is going to be a lot of fun. Of course, what I consider to be fun may not be what everybody thinks. But anyway, we've got calcium hydrogen carbonate, or calcium bicarb. And it's going to react with acid, hydrochloric acid, according to the reaction below. Okay, so every mole of calcium bicarbonate, all right, or hydrogen carbonate, okay, it's going to go react with 2 moles of hydrochloric acid. It's going to produce calcium chloride, and 2 moles of carbon dioxide and 2 moles of water. All right, so it first asks what volume of 0.235 molar hydrochloric acid solution must be present to totally react with the 0.14 moles of the calcium compound. Sounds hard. It really isn't. All right, so let's not worry about this right now. Let's figure how many moles of hydrochloric acid solution we've got to have to react with that many moles of the calcium compound. So it gives me moles. The good news is I don't have to convert to grams right now, right? So I've got 0.140 moles of calcium compound, which is the calcium bicarbonate, CaHCO3, 2. And in our reaction, how many moles do we need of the hydrochloric? For every 1 mole of calcium bicarb, I need 2 moles of acid. 2 mole HCl to 1 mole CaHCO3, 2. So the total amount of moles, or the total number of moles I need, okay, 0.14 times 2, that should be, times 2, should be, it is 0.28 moles. So I need 0.28 moles of acid, HCl. So I need 0.28 moles of HCl. All right, and I've got a concentrated solution of 0.235 molar HCl. So now I'm going to use that little formula we talked about, MV, or M1V1 equal M2V2, or molar volume, all right, moles per volume, or moles per liter, that's what molar is, times volume equal the number of moles I need. All right, so that's molar, that's the volume, and how many moles do I need? Because if I do that, it's going to get that. I don't know that. That's my unknown. I know I need 0.280 moles of HCl. All right, and I know the molarity, or the moles per volume. All right. So we're really not going to use that, but we're going to use that concept. So if I got 0.235 molar, or moles per volume, and moles per liter, okay, I don't know the volume. It's asking me for the volume, but I do know that I need 0.280 moles of HCl. So now I can do some really simple algebra, and if I want to get the volume by itself, 0.235 moles per liter, that's going to give me volume. That means I got to divide over here 0.235 moles per liter, 1 liter, okay. If I do that, 0.28 divided by 0.235, that's going to give me the amount of liters I need. And if I do the math, the liters are the V. This is red. I'm going to move over here, okay? The V is going to be 1.192 liters of 1.192 liters of acid solution. Problem solved. Again, you can see it's not that hard. We're using that concept, but we don't really need that, because if I do moles per volume, or moles times volume, or molarity times volume, this is going to give me the number of moles, because the volume will cancel out. So how many moles of water are produced when 0.491 grams, we got to convert to moles, of the calcium compound combines with excess HCl? So if we have more than 1.192 liters, right, that's the excess. So now I just got to do simple dimensional analysis or BCA table or whatever. Let's go with black. All right, so I've got 0.491 grams. I got grams of the Ca, what is it, HCO3 2 solution. All right, I got to convert that into moles. 1 mole of HCO3 2 solution. So that means I've got to do the molar mass or the atomic mass of all that. So calcium has a mass of 40.08 grams. Right, I've got one of those. Plus I've got, let's see, I've got 2 hydrogens, 0.0079 times 2, and I've got 2 carbons, 12.011 times 2, plus I've got 6 oxygens, 6 times 16, and I get 162.1178 grams. And notice I'm not rounding it, because I want to make sure that all my error, as much as possible, is gone. So 0.491, whoops, divided by 162.1178, I get 3.029 times 10 to the minus 3 moles of bicarb, or sodium bicarb, or calcium bicarb. All right. So I've got that 3.029 times 10 to the minus 3 moles. Just come up calcium. All right, just to show something. Now I look at my formula, and it's asking for the moles of water. So for every mole of calcium bicarb, I get 2 moles of water. All right, and it's only asking for moles. So for every 1 mole, of calcium, HCO3 I use 2 moles, or I can produce 2 moles of H2O. So all I've got to do is multiply that times 2, and I get 6.057 times 10 to the minus 3 moles H2O. All right. Block that problem in. Problem is worked. Question 20 is done. All right, Red Devil Chemist, this is Coach Scott saying peace out. I'm trying to stop.